Because if you do this in separate systems, then you have another problem like, what if you get actually structured data out of your unstructured data? How do you get that over the fence into this other system?
Hi, my name is Daniel Myers, Developer Relations here at Snowflake. Today, I'm interviewing Torsten Grabs, Director of Product Management. And today, we're going to be talking about data pipeline processing with Snowflake. Torsten, how are you?
Pretty good. How are you, Daniel?
Doing well, doing well. So to start this off, can you tell me a little bit about your role here at Snowflake, and some of the things that you work on?
So I had product management for our data lake, data science, and data engineering workloads. I've been at Snowflake for about 4 years. Yeah, it's been a lot of fun.
Awesome, awesome. So, what are some of the biggest shifts in building modern data pipelines that you've seen during your time here at Snowflake?
There are probably a couple that I would mention here. So the first one is with the new cloud computing paradigm, there's also a shift that happened from traditional ETL processing for data pipelines to ELT. And the reason for that really is that the traditional ETL tools didn't quite fit into the new cloud processing paradigm. And it turned out that oftentimes the target of these data pipelines was better suited to run large-scale transformations than these ETL tools. And then the roles flipped from ETL to ELT. That has been one of the kind of noticeable paradigm shifts. The second one that I would mention is that we are increasingly seeing more continuous processing. Traditionally, you had data pipelines oftentimes run in a batch processing mode during a maintenance window. And that was appropriate because you had very scarce resources, very limited capacity, and you wanted to make sure that you were doing these data pipelines during your idle periods, if you want, where you had capacity available. So you would wait for the weekend until you ran your data pipelines, right? The downside for that obviously was that your business results were always stale because your data was always behind by, let's say, a week, a day, or a couple of hours. Now, data today is born continuously, right? So data is being produced all the time by your mobile devices, by sensors. And with the cloud, now you have the ability to dynamically scale additional capacity for your data pipelines when you needed them. So you didn't have to wait for these idle periods anymore. And now you could afford essentially to process your data as it was born. And by doing that, then you also had more up-to-date business results because your data was no longer lagging. So that's the second one. There's a third one that I would mention as well, is that we are now increasingly seeing different kinds of data or a more comprehensive coverage of the kinds of data that are being processed. In the past, we had focused a lot on structured data, in particular in the context of data warehousing workloads. Now these boundaries between data warehousing and other workloads, they're blurring anyway. And as a result of that, now we have to essentially think about structured, semi-structured, and unstructured data. What we're seeing is that also the platforms that are doing this processing are consolidating. You do no longer want to have separate systems where one system deals with the structured data processing and a different system deals with your unstructured data. Because if you do this in separate systems, then you have another problem like, what if you get actually structured data out of your unstructured data? How do you get that over the fence into this other system, right? So today, customers expect that this is done with a single integrated platform, and no matter what your data looks like, whether it's structured, semi-structured, or unstructured.
Awesome. And so, what's really adding complexity there? So like when you're working with those three types of data, structured, semi-structured, unstructured data, it seems like there's definitely some complexity. What's adding that complexity there?
Probably the first one I would mention is that tools that we still use today have often still been designed in a time when the cloud was not there. So they haven't been architected for the cloud, and that oftentimes means that they either don't scale well or they don't offer a utilization-based business model, and that makes them hard to use. The other aspect then oftentimes is that you end up managing cloud resources at an infrastructure level. And that is time consuming and tedious. And it takes your focus away from the business problem that you want to solve. So if you can focus more on the business problem and leave the managing of resources and capacity to your platform, that frees up quality time for you to focus on what's more important. And we already talked a little bit about like different systems and integrating them in the context of structured, semi-structured, and unstructured data. I think that the general idea holds here as well. The more systems you have for kind of little different use cases and purposes, the more complexity you're adding to your data stack, and complexity always makes it hard to manage and scale a system. I'll mention that depending on what cloud provider you go to, you end up with different services for data storage, for data transformation. You have other services for advanced analytics and for data warehousing. So if you want to implement an end-to-end data pipeline across these various systems, you have to understand each individual one of them. They all have somewhat different semantics, somewhat different concepts, and you have to reconcile them. It makes it hard for developers and data engineers then to build these data pipelines, but it also makes data governance and compliance much more cumbersome than it needs to be.
That makes a lot of sense. And so where specifically does Snowflake fit into that kind of that ecosystem and paradigm?
Yeah, our goal here at Snowflake really is to take most, if not all, of that complexity away and give you that focus on the business problem that you want to solve. I'll mention a few things here. So the first one is Snowflake is a fully managed cloud service. It's a SaaS offering. So you should not need to worry about managing your infrastructure, your capacity, your compute resources at the infrastructure levels. We just talked about that is completely taken out of the equation. The other piece that's related is we have started to add more and more serverless capabilities to Snowflake. And that's great because it makes it even easier for you to manage capacity, and essentially you just pay for what you use. A minute ago, we also talked about structured, semi-structured, unstructured data. Snowflake, from the very beginning, put a lot of emphasis on supporting various data formats natively. And I mentioned data is born continuously. Oftentimes you see data being born these days in JSON. And JSON is a built-in native data format that Snowflake supports really well. So you can just essentially push your JSON data into Snowflake, and behind the scenes, Snowflake applies sophisticated physical optimizations to how the data is stored, so that you don't have to do that. So you don't have to go through a separate data pipeline that takes JSON as an input and produces Parquet on the output side. That happens automatically in Snowflake, and the data is put into the right shape to run really high performance analytics against your data. So thinking about high performance analytics, that takes us into like the performance territory. So Snowflake has an awesome query processor. It's very well suited for analytics, obviously. But then if you think about data pipelines, the interesting thing about data pipelines typically is that if you look at the analytics that you want to run, you have the choice. Do you want to do a certain type of processing in the analytics, in the report, or do you want to push that further down into your data pipeline, essentially front loading that piece of computation that you otherwise could do in the analytics? So if you have great horsepower for your analytics, then you typically also end up with great horsepower for your data pipelines, because if you take that piece of computation that sits in your analytics and you front load that into your data pipeline, then you will run the same transformation, the same processing, just in a different place in your data stack. But if your query processor, if your system can do that at high performance, you will benefit from that in your data pipeline as much as you would do in a report or in your advanced analytics processing. There's a lot to say about that, and we could go into more details about what makes the Snowflake engine great. I'll mention just another high-level point before we might be able to do that, which is supporting different languages that are appropriate for different personas. Obviously, there's the analyst. Most of them are fluent in SQL, but we know that data engineers and data scientists have sometimes other preferences. For instance, they would like to use a language like Scala or Java or Python. And we've started to embrace these languages in Snowflake as well. So we're currently previewing our Java and Scala capabilities. And the team is working on Python as well.
That's awesome. That's exciting. When you get into, Snowflake as being that processing engine, and you mentioned that shift from ETL to ELT. What makes Snowflake special in that state?
Probably the first piece that comes to mind is Snowflake has really been designed from the ground up for the cloud, for the public cloud. So we've taken a very disciplined approach at decoupling storage from compute, so you can scale both of them independently, and through the public cloud capabilities, you essentially get limitless scale for both of them. Now, the other aspect here that's really important is you want to make that scalability available in a truly elastic and instant way. So if you need that additional capacity, that additional horsepower, you don't want to wait for that to show up like 5, 10, 15 minutes later. You want that right away, right? Because that's when you see your burst in demand, and you want to be able to accommodate that right away. In particular, if you are running your data pipelines in a continuous way. So we've also then spent a lot of time to make sure that you can really within seconds get that additional capacity and horsepower when you need it. The other piece that's an implication of the decoupling from compute and storage is workload isolation. One additional aspect of like these maintenance windows back in the days was during the weekends, nobody else was working on the system. So you had automatic workload isolation for your data pipelines because nobody else was there, right? When you're running your data pipelines in a continuous way, that's no longer possible. Somebody will be working at that time. So you want to make sure that the system can actually make sure that you don't run into noisy neighbor issues, that you can actually run your data pipeline completely independent of your BI and your data science workloads. And that separation of compute and storage gives us that ability with Snowflake. And the underlying principle is all of that obviously operates on the same shared data sets, right? So everybody is collaborating on the same data, but is using different compute capacity to do that. The other part, we already talked about great performance. Some examples here that I mentioned, where does that great performance come from? So one piece that comes to mind is the micro partitioning that we do. Oftentimes in legacy systems, you have to really carefully think about the physical layout of your data, like how did you partition your tables, what clustering keys were you using, what indexes did you have to define. You don't need to do that with Snowflake. As you load your data, we're automatically partitioning it in these micro partitions, and we are generating the metadata that essentially automatically gives you the information that otherwise an index structure would provide. And we are using that to do what we call pruning, which is if you run a query against the system, we look at that metadata and we figure out which pieces of the data are actually relevant for the query. And then we only touch that data that you need to answer the question that you have in your query. And that obviously gives you a lot of performance benefits, but also it makes it much, much easier to use the system because you don't have to kind of do scrutiny in your workload and figure out, oh, I have to create this primary index, I have to create that secondary index. All of that comes out of the box when you just load the data, it's just there. And then obviously the physical layout that we use for the data is highly optimized for analytics, and that's done automatically. So we apply compression to the data so that you don't pay too much for storage and not more than necessary. We also put the data into a columnar representation, which makes a really good performance for your analytics workloads. And that is true for both structured and semi-structured data. I'll mention a few other things, like in the context of physical data storage, sometimes you have to think about like housekeeping tasks, like vacuuming, running some cleanup jobs. None of that is necessary for you to worry about. That happens behind the scenes. Snowflake does that automatically for you. The other part that's somewhat related to the query processor is also thinking about correctness consistency. And it goes back to some basic database principles with transactional guarantees. So Snowflake provides you with full transactional guarantees. And that's true no matter whether you touch a single table in your transaction or whether you actually run a more complex piece of business logic that touches multiple tables in the same transaction. You get these all or nothing properties, which are really, really important, because if you don't get them, then you have to worry about incomplete results, and then you have to write all sorts of code to protect against them. If something happens, you may have to run kind of weekend jobs to clean up your data. So that makes life much easier for developers and for people that are running the system. And we're also kind of following the same principle for some of the features that we're putting in our data pipelines. So we have our table change streams that give you the ability to do essentially change data capture on a staging table. And the way that we've implemented the feature makes it reliable through transactions. So you can look at your changes and then transactionally consume them and move them forward into a target table and apply transaction semantics to that, which gives you these all or nothing properties, which is really great, because you get these exactly one semantics. You don't have to worry about duplicate data or data corruption, which is a real pain when you end up with that.
Yeah, I mean, that's incredibly powerful. So when we take the concept of Snowflake being the processing engine, how does that fit into the broader sense of Snowflake's data cloud concept?
So if you think about the data cloud is not just about static data assets that just sit there. The data cloud is really about collaboration over shared data. And how does that collaboration happen? That collaboration happens when people get access to their mutual data sets and can look at them, can work at them. But it really gets powerful if people start thinking about their value chain and how are they implementing their value chains across these shared data assets. And those then, if you implement them, those result into data pipelines. And these data pipelines, you might just initially think of them as something that you run internally in your business. But if you think about them at the data cloud level, you want to run your data pipelines across your business partners, across your customers, your consumers, your clients. All of them collaborate over this data, and they add value by running these end-to-end data pipelines that stretch across the data cloud. In general, the way to think about the data cloud is the more access you have to data and the better the quality of the data is that you get access to, the better business outcomes you will get. And that holds true for everyone who participates in that data cloud setting, right? And what makes it so powerful is that everybody in the data cloud operates over the same single logical copy of a data item. So if someone changes it, it becomes immediately visible to the other participants. And you don't end up with a problem of having multiple different copies of the same piece of data in various places. That's a maintenance nightmare, because you want to make sure that thing stays consistent across these different places. It's also a governance nightmare, because if you end up with that, then you need to make sure that the same policies and principles are applied in all these various places.
So you just mentioned, the policies and principles, in all these different places, for our viewers and for people that are looking to, learn more about Snowflake, what are some key pieces of advice that you would recommend to them?
That's a good question. I think the first one I would mention is take a critical look at all of your data pipelines, in particular those that just seem to optimize the physical layout of your data rather than adding business value to what you do with your data. And then ask yourself the question, is there a better and simpler way to do this? And I will argue, yes, there a lot of these pieces that we just talked about in the context of Snowflake should take a lot of that burden and overhead away and make this much simpler for you. The second one is kind of more generally thinking about your architecture and your data stack. How convoluted is that? Do you really feel happy with where you ended up? At the beginning of our chat, we talked about like all these various services somehow interacting with each other and kind of data pipelines stretching across a multitude of services. Are you seeing that a complexity in your data stack as well? Do you feel that it is really necessary and that it adds value? And look for opportunities there again to simplify, because the simpler typically your data stack gets, the easier it is to scale and to maintain and to cover. Complexity is the enemy of scale. So the fewer different services you are running, then I'd say the better shape you are in. And also look carefully at where are your teams spending their time, right? Are they optimizing physical things? Are they managing infrastructure and resources, or are they spending their time on answering business questions, right? The last piece I'll mention is really start thinking about your data as a product of your organization. And look for ways that you can liberate your data, and ways how you can collaborate over data with others. And if you do that, then what is the additional value that you can create with your data pipelines when they stretch across companies, regions, continents, or even cloud providers?
Yeah, that makes a lot of sense. So Torsten, thank you, for coming on today and talking today about, Snowflake and being the data processing engine. For people that want to learn more about this topic, and for people that may want to follow you online, where should they go to learn more?
And for sure, I would say, go check out the Snowflake documentation, check out the Snowflake blog. And also our YouTube videos are great resources there. And we oftentimes have people show demos there. So that's a great place to check out. Last but not least, if you haven't tried Snowflake yet, it's very easy to get a trial account on our website. So just go there, sign up for one, and check things out.
That's awesome. That's awesome. And the last thing I want to give to everybody here is definitely check out our community.snowflake.com website, where you'll be able to connect with other Snowflake experts, other people in the community all around Snowflake. You'll even be able to find a local chapter possibly around and be able to meet up with other Snowflake enthusiasts. So my name is Daniel Myers, and this is another episode of Behind the Data Cloud. Thanks.